The cache hierarchy reduces average memory access latency.
The cache hierarchy reduces average memory access latency.
L1 cache provides single-cycle access for hits.
L1 cache provides single-cycle access for hits.
Cache hit rate determines effective performance.
Cache hit rate determines effective performance.
We're using set associative cache organization.
We're using set associative cache organization.
The cache line size is 64 bytes.
The cache line size is 64 bytes.
Spatial locality benefits from larger cache lines.
Spatial locality benefits from larger cache lines.
Temporal locality is exploited by cache retention.
Temporal locality is exploited by cache retention.
The cache miss penalty increases at each level.
The cache miss penalty increases at each level.
We need to optimize for working set size.
We need to optimize for working set size.
Direct mapped caches have lower access latency.
Direct mapped caches have lower access latency.
Higher associativity reduces conflict misses.
Higher associativity reduces conflict misses.
The tag array stores address metadata.
The tag array stores address metadata.
Cache index bits select the set.
Cache index bits select the set.
The offset bits address bytes within a line.
The offset bits address bytes within a line.
We're implementing virtually indexed physically tagged cache.
We're implementing virtually indexed physically tagged cache.
The cache access time impacts processor frequency.
The cache access time impacts processor frequency.
Write policies include write back and write through.
Write policies include write back and write through.
The dirty bit tracks modified cache lines.
The dirty bit tracks modified cache lines.
Cache capacity is limited by area and power.
Cache capacity is limited by area and power.
We need to balance size and access latency.
We need to balance size and access latency.
MESI protocol maintains cache coherence in multicore.
MESI protocol maintains cache coherence in multicore.
Modified state indicates exclusive dirty data.
Modified state indicates exclusive dirty data.
Exclusive state allows silent upgrade to modified.
Exclusive state allows silent upgrade to modified.
Shared state requires invalidation before write.
Shared state requires invalidation before write.
Invalid state triggers cache line fetch on access.
Invalid state triggers cache line fetch on access.
Snooping protocols broadcast coherence messages.
Snooping protocols broadcast coherence messages.
Directory-based coherence scales to many cores.
Directory-based coherence scales to many cores.
We're implementing MOESI with owned state.
We're implementing MOESI with owned state.
Cache-to-cache transfers reduce memory traffic.
Cache-to-cache transfers reduce memory traffic.
The coherence protocol impacts cache miss latency.
The coherence protocol impacts cache miss latency.
False sharing causes unnecessary coherence traffic.
False sharing causes unnecessary coherence traffic.
We need to optimize data structure alignment.
We need to optimize data structure alignment.
Memory consistency model defines ordering guarantees.
Memory consistency model defines ordering guarantees.
Store buffers enable write latency hiding.
Store buffers enable write latency hiding.
The load store queue enforces memory ordering.
The load store queue enforces memory ordering.
Sequential consistency is strongest but slowest.
Sequential consistency is strongest but slowest.
Relaxed consistency models improve performance.
Relaxed consistency models improve performance.
Memory barriers enforce ordering constraints.
Memory barriers enforce ordering constraints.
We're implementing SO memory model.
We're implementing TSO memory model.
Coherence traffic consumes interconnect bandwidth.
Coherence traffic consumes interconnect bandwidth.
Prefetching hides memory access latency.
Prefetching hides memory access latency.
Stride prefetchers detect sequential patterns.
Stride prefetchers detect sequential patterns.
Stream buffers capture sequential accesses.
Stream buffers capture sequential accesses.
We're implementing neural network prefetching.
We're implementing neural network prefetching.
Prefetch accuracy affects cache pollution.
Prefetch accuracy affects cache pollution.
Aggressive prefetching can waste bandwidth.
Aggressive prefetching can waste bandwidth.
The prefetch distance must match memory latency.
The prefetch distance must match memory latency.
We need to throttle prefetching under pressure.
We need to throttle prefetching under pressure.
Cache replacement policy affects miss rate.
Cache replacement policy affects miss rate.
LRU approximates optimal replacement.
LRU approximates optimal replacement.
Pseudo-LRU reduces implementation cost.
Pseudo-LRU reduces implementation cost.
We're evaluating adaptive replacement algorithms.
We're evaluating adaptive replacement algorithms.
Dead block prediction improves replacement.
Dead block prediction improves replacement.
Cache bypass avoids polluting for streaming data.
Cache bypass avoids polluting for streaming data.
Victim caches capture recently evicted lines.
Victim caches capture recently evicted lines.
The working set must fit in cache for good performance.
The working set must fit in cache for good performance.
Cache partitioning prevents interference.
Cache partitioning prevents interference.
We're implementing way-based partitioning.
We're implementing way-based partitioning.
Cache compression increases effective capacity.
Cache compression increases effective capacity.
The compression ratio depends on data patterns.
The compression ratio depends on data patterns.
Inclusive caches simplify coherence protocols.
Inclusive caches simplify coherence protocols.
Exclusive caches maximize aggregate capacity.
Exclusive caches maximize aggregate capacity.
Non-inclusive caches offer flexibility.
Non-inclusive caches offer flexibility.
The L2 cache acts as victim cache for L1.
The L2 cache acts as victim cache for L1.
Shared L3 cache enables core-to-core sharing.
Shared L3 cache enables core-to-core sharing.
We're implementing per-core L2 slices.
We're implementing per-core L2 slices.
The last level cache is distributed across die.
The last level cache is distributed across die.
Cache access latency increases with distance.
Cache access latency increases with distance.
We need to optimize for NUMA effects.
We need to optimize for NUMA effects.
The cache hierarchy depth affects complexity.
The cache hierarchy depth affects complexity.
Write buffers absorb store traffic.
Write buffers absorb store traffic.
Fill buffers handle outstanding misses.
Fill buffers handle outstanding misses.
The miss status holding registers track in-flight requests.
The miss status holding registers track in-flight requests.
Cache bank conflicts reduce effective bandwidth.
Cache bank conflicts reduce effective bandwidth.
We're implementing non-blocking cache architecture.
We're implementing non-blocking cache architecture.
The TLB caches page table entries.
The TLB caches page table entries.
TLB misses trigger hardware page walks.
TLB misses trigger hardware page walks.
We're using two-level TLB hierarchy.
We're using two-level TLB hierarchy.
Huge pages reduce TLB pressure.
Huge pages reduce TLB pressure.
The TLB reach determines translation coverage.
The TLB reach determines translation coverage.
Address translation is on critical path.
Address translation is on critical path.
We need to optimize TLB hit latency.
We need to optimize TLB hit latency.
Page table walks access multiple memory levels.
Page table walks access multiple memory levels.
The page walker caches intermediate entries.
The page walker caches intermediate entries.
TLB shootdown causes interprocessor interrupts.
TLB shootdown causes interprocessor interrupts.
PCID tags avoid TLB flushes on context switch.
PCID tags avoid TLB flushes on context switch.
We're implementing shared TLBs across cores.
We're implementing shared TLBs across cores.
The ITLB handles instruction fetch translations.
The ITLB handles instruction fetch translations.
The DTLB handles data access translations.
The DTLB handles data access translations.
TLB mislatency impacts application performance.
TLB mislatency impacts application performance.
Memory level parallelism overlaps multiple misses.
Memory level parallelism overlaps multiple misses.
Out-of-order execution hides cache mislatency.
Out-of-order execution hides cache mislatency.
The memory request buffer tracks pending accesses.
The memory request buffer tracks pending accesses.
We're implementing cache quality of service.
We're implementing cache quality of service.
Priority-based allocation prevents hogging.
Priority-based allocation prevents hogging.
Cache monitoring tracks per core utilization.
Cache monitoring tracks per core utilization.
The cache access energy dominates power budget.
The cache access energy dominates power budget.
We need to implement drowsy cache for low power.
We need to implement drowsy cache for low power.
Cache coherence traffic is 30% of total bandwidth.
Cache coherence traffic is 30% of total bandwidth.
The memory hierarchy design is critical for performance.
The memory hierarchy design is critical for performance.